Thank you, Professor Sangwai. This was a wonderful talk, and specifically the information that you presented was quite comprehensive. And for anybody who is working in the field of carbon storage or something related to gas hydrates, this is an eye opener. So thank you for that. So we'll start off with a very fundamental question, and a couple of the questions they have already put together. So I'll just try to group them. People just want to explore, what is the role of, promoters in hydrate formation, and they just want to have an understanding around, what type of promoter should they use. Should they use something of, chemical origin or a biological origin, and some of your insight around promoters to be used.
Yeah. So the promoters are important in hydrate formation because you want to increase the reaction rate of CO2 and water to form hydrates. So promoters are two categories primarily. There are thermodynamic promoters and there are kinetic promoters. So thermodynamic promoters actually ensures that the pressure conditions required are milder and the temperatures are higher on higher side. So the promoters reduces the required pressure and increases the temperature to form hydrate. And then there are kinetic promoters, which does not affect the phase stability of CO2 hydrates, but they improve the rate of reaction. So the amount of gas that is getting consumed. Now, there are various promoters reported for flow assurance problems where because hydrates also forms in pipeline methane hydrates, and there are promoters, there are inhibitors which are reported. There are promoters also reported for methane hydrate in order to store methane in the form of hydrates at surface condition. However, here what we are looking at is the promoters which should be environment friendly because you're talking about ocean and then it should not affect the marine life. So these promoters should be from biological origin. That is what is recommended. And people are trying to look at various amino acids and some of the promoters which may possibly help us to promote CO2 hydrate formation at subsea conditions. The stability of CO2 hydrate or these promoters at those saline conditions are again one of the areas where people can again look at for further studies.
Okay, thank you, Professor. Yeah. So there are a couple of questions regarding the pH and what is the effect of the acidity on or like the variation of pH on gas hydrate stability. And there's another question around if we sequester a lot of carbon into the seawater or in any form of water, it tends to form carbonic acid, which albeit is a very weak acid, but will that acidification impact somehow the marine life or the stability of gas hydrates?
Yes. So this is a good question, and this is everybody actually wonder about. So I have shown you one of the slide where we are talking about 1100 to 1500 gigatons of CO2 to be captured and sequestered in the long term. Looking at the amount of change in pH that is reported in literature, we don't expect that the pH may change. Looking at the overall capacity of the sea. However, when you try to inject that CO2 at a localized condition, the pH may vary. And of course, one need to understand the localized impact of those CO2 injection point and how much pH that may change. As I said, like as you all correctly pointed out that the CO2 may also convert into carbonic acid and some of these aspects. Research is not being reported in literature specifically understanding their impact on the marine lives. However, what is expected that the CO2 that is being sequestered may also turn into carbonates or bicarbonates at those conditions over a period of time, and that may slowly, stabilize, if not form hydrates. And if form hydrates, then hydrate will remain stable depending upon the sea depth and the localized pressure and temperature conditions.
Thank you. So, yeah. Professor, there's a follow-up question to that since we are sequestering so much CO2 into the oceans and forming gas hydrates, will there be any impact on, the seismic stability and some form of, untoward, geological activity may take place if we are storing CO2? So the audience just has some questions around that.
So seismic stability will not change if you talk about the subsea sediment, because I have already reported that methane hydrates are already there. Mother Nature has captured methane, which otherwise would have come into the atmosphere and we would not have been able to live into the Earth atmosphere. Mother Nature has captured that methane in form of hydrate, and that process is happening for millions of years, and you see that significant amount of methane hydrates are lying on the seabed. And these are solid compounds. These are like ice-like compounds. Similarly, if you form CO2 hydrate, these are like ice-like compounds. So we are not really affecting the sediment stability because we are actually forming there something which is a solid. and therefore seismic stability will be intact, will not change. Now, in case the hydrate dissociates, then that may affect the stability. But again, as I discussed in my talk, that it again depends upon the depth at which you are injecting CO2 and forming hydrates. Because at shallower depth, it's possible that the CO2 may get released from this hydrate structure in case there is a seismic activity that happens. And then it may come back into the ocean and so on and so forth. However, at certain depth, as I said, the CO2 is more denser than the seawater, and therefore it may tends to settle down again over a period of time. So the seismic activity and stability is again one of the areas where people can actually look at, further research and understand overall impact at the subsea conditions.
So there's a question around here that, we are working with so many different methods of carbon storage. So people are also exploring geosequestration. People are exploring some form of carbon mineralization. People are also exploring, carbon utilization in form of, chemicals like methanol or some other, useful chemicals.
Yes.
And all those research is being done, and all that form of research is very important. But what's your take on that which is the most important and the best mature technology currently for CO2 storage?
So right now, the mature technology for CO2 storage is onshore geological sequestration, specifically in the depleted oil and gas reservoir, because we have those reservoirs available for sequestration of CO2, and it is in fact being practiced by oil and gas industry even for enhanced oil recovery. And studies shows that we can actually, the data that is reported in the literature shows that you can even make a oil and gas industry carbon neutral if you ensure injecting the CO2 into the geological formation and producing oil from the surface. So it has been reported that if you burn 1 barrel of oil and that much of amount of CO2, whatever that you are producing, the same amount of CO2 can be injected back into the geological formation. So that is more mature technology that is available. And onshore geological formations are also very potential, and promising ways to capture and sequester CO2 into the subsurface geological formations. And these are very safe, because oil and gas industry is very matured, and knowledge about geological formations are also very matured, and we can actually properly seal that CO2 for long-term storage. Also, it has been reported that basalt formation and some of these areas where CO2 can be sequestered and mineralized for long-term storage. So everything is possible. As a researcher, everything is important. And whichever means, we have to go ahead and make sure that we are safe.
Thank you, sir. And with that, we'll come to the end of our session. I thank you so much for taking the time out of your busy schedule and being here with us. And also thank my audience for being patient with us. And Kunal, over to you.
Thank you, Krishna, and thank you, Professor Sangwai. Wonderful presentation, and thank you so much for giving us this extra time and allowing the audience to answer and get their questions answered. And as you can see, so many emojis coming up. So this brings us to the end of today's session. We hope that you have enjoyed this broadcast. We invite you to view the edited recordings from the past events in the ACS Science Talks library. At the end of the session, and my colleagues have also posted the link for a survey in the chat. So please do share your feedback with us so that we can continue to improve and serve you better. On behalf of all of us at ACS, thank you for joining us today. We hope to see you again soon for more ACS events. Until then, stay safe and healthy.